I'm Anil Kumar. Welcome to my series on vectors. Here are questions from recent test papers, Unit 2. We'll talk about dot product, cross product, and their applications. So I've taken all the questions from this particular test paper. Let me thank my brilliant student Gurmeen for getting excellent marks and also being judged as one of the best students in her school. So these are the questions which we are going to look into. Right? So for your convenience, I have copied all the questions and I have also added few more to give you a good overview on this unit. So let me first share with you the questions which we are going to discuss. So I hope you can see the first 4 questions. You can always pause the video, answer these questions, make a copy. These are the other questions on this particular page. So 9 questions here on the first page, and then we have 5 questions on this particular page. Right? So we are going to answer all these questions in this particular video. I hope that should give you good practice. We'll also try to understand some concepts as we move along. Question number 1. If magnitude of vector A is equal to 3 and that of B is 4 and the angle between these two vectors is 60 degrees, the numerical value of 2a plus b dot a minus 3b is what? So let's figure this out. So we need to find what is 2a plus b dot a minus 3b, right? Where the magnitudes of vector a and b are 3 and 4 respectively. So when you multiply, rather I should say dot product, then we have 2a dot a minus 3 times 2 is 6 a dot b plus b dot a minus 3 b dot b. Now a dot a is magnitude of a square. 6a dot b plus b dot a. B dot a and a dot b are one and the same things. Commutative law holds good for dot product. So we get minus 5 a dot b. And this is minus 3 magnitude of b whole square. So we're given all these values. Magnitude of a is 3. So we can write this as 3 square minus 5 times a dot b. We can find out since we know that the vectors are at an angle of 60 degrees, right? So let's find what is a dot b. So vector a dot b will be equals to magnitude of a times magnitude of b times cos of the angle, which is 60 degrees between them. So this is 3 times 4 times cos of 60 degrees. Now cos of 60 degrees is half, right? So it is 3 times 4 times half, right? You can use calculator also, which is 6. So this value here will be 5 times 6. Is that clear? Minus 3 times magnitude of b square, which is 4 square, right? So which is 2 times 9 minus 30 minus 16 times 3, which is 48, right? Anyway, let's use calculator and find the answer. So we have 2 times 9 minus 30 minus 48. That gives you minus 60 as your answer. So option B is the right option. Is that clear to you? So that is how you're going to solve the very first question. Question number 2. A box is pushed 3 meters across the floor against a frictional force of 200 newtons. The amount of work done will be product of these two, right? So which is 600 Newton meters or joules? So option B is the right option. Clear? Now let's look into the next question, which is, if magnitude of A is 2, magnitude of B is square root 2, and A dot B is 2, then the angle between these two vectors is what? So A dot B is basically equal to magnitude of A times magnitude of B times cos of angle between them. A dot B is 2. Their magnitudes are given to us, 2 times square root of 2. We need to find the angle theta. So we can clearly get this as 2 times square root 2 equals to cos of theta. 2 and 2 cancel. So that gives you theta as 45 degrees. Clear? Since cos theta is 1 over square root 2. Question number 4. What is the dot product of these two? So let's find the dot product, which is 4 minus 10, 3 dot 11, 1, 5, which is 4 times 1 is 4, minus 10, 5 times 3, 15 plus. So that gives you 5 plus 4 as 9. So option D is the right option. Clear? Now let's move on and take question number 5. What is the scalar projection of A on B? Now scalar projection basically means what? It means it is only the magnitude, right? So scalar projection of Y on X we need to find, correct? So you need to find the dot product of these two, which is Y dot X divided by the magnitude of X. Clear? So in this case, it is 1, 0, minus 4 dot 5, 2, 1 over magnitude of X is square root of 5 square plus 2 square plus 1. Clear? So dot product, it is 5 plus 0 minus 4 over, this is 25 plus 4, which is 29, plus 1, which is 30. So we get 1 over square root of 30. Remember, this projection will always be positive, right? So we get option D as our answer. We're talking about the magnitude, right? Question 6. Write vector projection of X, Y on X, right? So when we say vector projection, it has the direction, and direction is in X direction, right? So now I could have written like this, right? We're just talking about the this magnitude part. Now this is a scalar quantity, so we get the answer. Well, now we want this as a vector projection of Y on X. So the vector position is, so when you get the dot product of A and B, you get a magnitude, right? So which is minus 3, 4, 0 dot 2, 1, 4, right? So that is the dot product which gives you the magnitude. And here we can do B dot B, right? So I didn't write the formula anyway. So X dot X, that is X square, right? So 2 absolute value of X square, 4 dot 214 times, so this will be the scalar part, scalar multiple of the vector, which is 214, right? So this actually gives you the direction. It is in the same direction as the vector X, correct? So which is minus 6 plus 4 plus 0 over, and here we get 2 times 2, 4, plus 1 plus 16, and this is times 2, 1, 4. Okay. So in the numerator, we get minus 2, let me write down, minus 2 over 21, okay, and 214. Okay, so that is our first option, option A is the right option. So that is how we are going to solve it. Now let's look into question 7. I would like you to pause the video here, solve the question yourself, and then look into my suggestions. Question number 7, vector A and B are given to you. You need to find the cross product. So the cross product of A and B is equal to, we can write ijk, it's a vector, right? So A is 4, minus 6, 10, B is minus 6, 9, minus 15, right? So that gives me I. These are the unit vectors times this determinant. So 6 times 15, 6, 5 is 30, that is 90, minus 90, okay? Minus j times these components, 4 times, that is 60 with a negative sign, and that negative makes it positive 60, plus k, 9 times 4 is 36, minus this, which is also 36. So clearly we get 0, 0, 0. So option C is the right option. Clear? Question number 8. Show that A times B dot B minus B dot B is perpendicular to vector B. Now, if you have to prove that two vectors are perpendicular, let's say we have vector x and we have vector y. So if their dot product is equal to 0, then the vector x is perpendicular to vector y, correct? So basically, we need to show that vector A, B dot B minus vector A dot B, all this dot B is equal to 0. That is what we need to prove, right? So let's begin with the left side. So the left side here is dot product. Let's do this. So we get A dot B, right? And here we have B dot B minus we have A dot B, and here we get B dot B, correct? Now B dot B is magnitude of B squared, right? Anyway, you see both the terms, right? They're exactly same, right? So we have A dot B times magnitude of B squared minus A dot B times magnitude of B squared. So this definitely is equal to 0, right? Since it is 0, we know they are perpendicular, right? So hence proved. Okay. Now let's take question number 9. Describe the octant in which the point A2 minus 1, 3 lies. Find direction angles of position vector OA. Now this is a very important question. Let's first try to understand how to describe the octants. We are talking about R3, right? So let me just sketch and show you. So here we have the x-axis, y-axis, and the z. When we say the point is 2 minus 1, 3, so 2 means 2 units on this side, minus 1 means you're going to the left side, right? So this is the left side, so you've come to the left side, and then you've gone up 3 units, right? So it is not to the scale, so let's say this is 3 units, okay. So how do we describe the octant? So the octant is basically on the left side, right, and is on above. So basically there are 8 octants to describe any point. So here what we see here is that we move left of the x-axis and we go above, and all this is happening in front, right? So we say left above you're going to actually write front first. Since I want to associate this with x value is positive means it is in front. This negative means it is left side, and this positive means above, right? So in R3, you will notice that it's important to see this way. In R3, we're talking about the values x, y, and z. Now each one could be positive or negative, right? So we could have a positive value or a negative value, right? So these positive and negative values give rise to 8 octants. And these octants are described. If x is positive, we mean front and then back. So I wrote front first. Y, left is for negative, right is for positive, and z, up, going upwards or above, is positive and negative is going down. Is that clear to you, right? So that is how we describe our octants. So in our case, the point A, which we are talking about, is 2, minus 1, 3. So 2 is positive, that means it is front. Minus y value is negative, that means left. And 3 is positive, that means above. So the point is placed in this octant, left, front, and above in any order. Is that clear to you? So that is how you're going to describe. So that is our part 9a. Now let's find the direction angles of the position vector OA. So that is the position vector OA, right? Now direction angles means angles with the x-axis, the y-axis, and the z-axis. Is that clear to you? So these are the 3 angles which we are looking into. So let's find the magnitude of A first. So what is the magnitude of A? Which is square root of 2 square plus minus 1 square plus 3 square, which is square root of 4 plus 1 plus 9, square root of 14, right? Now all these angles, direction angles, are alpha, beta, and gamma, right? So this angle with the x-axis will be alpha, the one with y-axis will be beta, and one with z-axis is going to be gamma, right? So the value of alpha will be cos inverse of 2 over square root 14. Beta is going to be cos inverse of minus 1 over square root 14. And gamma is going to be cos inverse of 3 over square root 14. Okay, let's figure this out. So we have shift cos inverse 2 divided by square root 14 within brackets is equal to, so we can write this as 57.7 degrees. For beta, it is minus 1 over square root 15. So let's change this to 2 to minus 1. And now the answer is 105.5 degrees, right? For gamma, it is 3 over square root 15. So let's change this to 3 now. So that gives you 36.7 degrees. Is that clear to you? So that is how we find the direction angles for the vector OA. Is that clear to you, right? So our answer here is alpha equals to 57.7 degrees, beta equals to 105.5 degrees, and gamma is equal to 36.7 degrees. Clear? Question number 10. State whether each statement is true or false. Assume all the vectors as non-zero vectors. Justify your choice. A plus B plus C equals to 0. then the three vectors are in state of equilibrium. Yes, that is true, right? So if we can form a triangle, for example, kind of like this, right? So we have A plus B plus C, then it is in the state of equilibrium. Okay. If two vectors are unit vectors pointing in opposite directions, then the dot product is 1. Well, if we have one vector like this, one vector like that, in that case the angle between them is how much? It is 180 degrees, right? And now that is minus 1, right? So we have cos of 180 degrees is minus 1. So this is not 1 but negative 1. So this statement is false. See, if A and B are vectors in R3, then A dot B, which is scalar, A cross B, is a meaningless thing. So that is false, since what we have here is a scalar product. Because as you can see, A dot B is scalar, and that is vector. So we do have scalar product in vectors, so that is not meaningless. D. Cross product of two orthogonal vectors is 0. So when you're talking about orthogonal means perpendicular, that means the angle between them is, that means we are looking for sine of 90 degrees, right? Now, sine of 90 degrees is not 0, correct? Sine of 0 is 0. So cross product we are talking about. So cross product of two orthogonal vectors is 0 is false. Dot product is 0. E. The points P, Q, R and S are the vertices of a quadrilateral whose diagonals intersect at right angles. Okay. So in this particular case, we have this P, Q and R. So the diagonals will be PR and QS, right? So let's find what is PR first. So PR, P to R will be 1 minus 2, which is minus 1, 3 minus 4, which is again minus 1, minus 2 minus 0 is minus 2. And so we have PR, then we have QS. Let's find what is QS. So minus 4 minus 3 will be 7, minus 5, this will be 7, and sorry, minus 7, right? Minus 5 minus 2. 5 minus 5 will be 0. So let's find the dot product, right? So let's say dot product of these two, which is minus 1 minus 1 minus 2 dot 7 minus 7, 0. So if I do this dot product, we get minus 7. Let's do this. We get minus 7. Minus 7, this is plus 7, and that is 0. And this is indeed 0. So we have this as 0. Therefore, they intersect at right angles. This statement is true. Correct? So find the dot product of the diagonals. If it is 0, then they intersect at right angles. So I hope that is absolutely clear. Question number 11. Consider the parallelogram ABCD. So let's make one. Okay. So ABCD, so where A is 0, 1, 2, B is 1, 2 and minus 3, and C is 2, 1 and 0. So that is D, right? Okay. Find coordinates of vertex D. We need to find in this parallelogram coordinates of vertex D. So these sides are also equal and they are parallel. Find the angle B. We need to find this angle B. And find the area of the triangle ABC. So these are the three parts. So let's figure out how do we find D. Now since these two sides are equal and parallel, we know BC should be equal to AD, right? So we know that BC should be equal to AD. So BC is what? BC is 2 minus 1, 2 minus 1. B to C, 1 minus 2, 1 minus 2, and 0 minus 3, 0 plus 3, correct? And A to D is, let's say this is X, Y, Z. So it is X minus 0, Y minus 1, and Z minus 2, correct? So if you compare, you get X equals to 2 minus 1, which is 1. Y equals to, this is minus 1, so Y minus 1, so Y is minus 1, and that goes on this side, plus 1, which is 0, and Z minus 2 will be 3, so Z will be 3 plus 2, which is 5. Is that clear to you, right? So if I write Z as 5, I do get 5 minus 2 as 3, just checking. 0 minus 1 is minus 1, that matches, and 1 minus 0 is 2 minus 1, same thing. So we get the coordinates of D, so we could write D as 1, 0, 5. Is that clear? Now we need to find angle B and the area of the triangle ABC. To find angle B, we could use dot product. Okay, so let's do part B now. So AB, so we need to find angle B. So what we will do is, we'll do BA dot BC. That should be equal to magnitude of BA times magnitude of BC times, so we are doing BABC, let's say this angle, cos theta, right? We need to find this angle. So we have to find the angle B, I am assuming that, inside angle, right? So BA dot BC, so BA, okay, it was better if we could have written this earlier. BA means 0 minus 1, okay? So I'm writing now, 0 minus 1 is minus 1, 1 minus 2, which is minus 1, 2 minus, that becomes 5, dot. BC is 2 minus 1, which is 1, 1 minus 2 is minus 1, 0 minus 3 is 3, right? We have to find cos theta, so I'll divide by the magnitude of BA and BC. So magnitude of BA will be 1 square plus 1 square plus 5, which is square root of 27. Is it clear? And this magnitude is 1 plus 1 plus 9, so it is 11, right? Okay, so let's find the dot product. 1 time 1 dot minus 1 is minus 1, this is plus 1, and this is 15 over square root of 27 times square root of 11. So this is our cos theta. Let me write here. So which is 15 over square root of 27 times square root of 11, right? Let's figure this out. So we have 15 divided by, within brackets, square root of 27, okay, times square root of 11 equals to. So we got some number which is 0.87, okay. So theta is cos inverse of 0.87. Shift cos inverse of our answer is equal to 29.49. So we get 29.49 degrees, or you can say 29.5 degrees as angle B. Correct? Now let us find the area of the triangle ABC. So triangle ABC is half the area of the parallelogram. Do you see that? So to find this area, we should do cross product, correct? So we'll do cross product of AB and BC, okay? Or we can say, since we are looking into magnitude, we can do cross product of these two, right? So let's do cross product of, to find the area, we are saying magnitude of We can even write in this fashion, right? So BA cross BC, that is what? Magnitude. So this gives you the area of the parallelogram. So half of this will be area of the triangle. We're talking about this triangle. Is that clear to you? Triangle, right? So triangle area. Let's do part C now. So I've kind of written all these things in a very small space, but I hope it makes sense to you, right? Okay, so let's find this magnitude. So these are the two vectors, or we can say I, j, k, and this is -1, -1, 5, 1, -1, 3. Okay, so let me push this a bit. So we get, using a different ink, I. So this will give us -3, minus that will give me, makes it +5, right? Minus j times. So this is -3, and that gives me -5 plus k. So that gives me +1. This gives me -1. Minus and minus becomes +1, right? Okay. So that is 2i minus becomes +8j, and that is +2k, right? So that is your vector. So we can say the magnitude of this will be what? So the area will be equals to square root of this, which is 2 square plus 8 square plus 2 square, which is square root of 4 plus 64 plus 4. 68, 72 square root. Correct? So we get square root of 72, and since we are interested in area of a triangle, we'll do half of this. Clear? Divided by 2. Is that clear? So that is how we can do. 72 is 16, is a multiple of 16, but let's use calculator, right? Square root of 72 equals to divided by 2. So we get 3 square root 2, or in decimals, you could write this as 4.24 units square. Okay, so let's look into what we did to solve question number 11. It is indeed a very important question from any test point of view. We are given a parallelogram ABCD. A, B, C, the three vertices were given to us. We need to find D. AD is same as BC, and equating that, we could find the coordinates of D. Easy ways. See by how much we change when we move from B to C. As far as x value is concerned, it increased by 1. When you add to 0, you get 1. 2 to 1 decreased by 1, so 1 minus 1 is 0. Minus 3 to 0 means add 3. Add 3 to 2, you get 5. So you get 1, 0, 5 as the coordinate points of D. Then we need to find the angle B. Now to find the angle B, we'll use dot product. BA dot BC is magnitude of BA, magnitude of BC, cos theta. Now it is a good practice in this. First you define what BA and BC is, right? So that is very important. We did it on the fly. But in fact, you should actually do it separately. You first find what is the vector BA, right? So vector BA is -1, -1, 5. And vector BC is 1, -1, 3. 1, -1, 3. Also, you can find their magnitudes so that you could write these values directly. Cos theta will be A dot B divided by their product of their magnitudes. So we found the angle theta between them using the dot product. Third part was to find the area of triangle ABC. Important thing is triangle, not parallelogram. So we'll do half times the cross product of these two. Right? So since we are talking about magnitude, so I wrote BA and BC. Okay. And we found the cross product, got the vector. Then half times the magnitude of this vector gives us the area of the triangle. Unit square will be the units. It is good to mention. Okay, let's move on and take the next question, which is question number 12. Question number 12 here is, a pilot wishes to fly 400 kilometers per hour north. Okay. Due to wind, the pilot has to actually fly 430 kilometers per hour in the direction of from north 5 degrees east. Okay. Right. So let's try to make this diagram here. Determine the velocity that is causing him to adjust his course. So velocity of wind velocity. Okay. So basically, we want to go north. So that is what is expected. But instead, because of the wind, it went like this. Right? I know this is much more than 5 degrees, but just to make things clear. So the wind pushed it to the desired location. So that is the wind. So what we are given here is that this angle is 5 degrees. Perfect. And this side represents 400 and the other side represents 430. We need to find the wind velocity. Let's say W, right? Now in this particular triangle, clearly we can use cosine law. Correct? And find the vector wind velocity, right? So from here we can say wind is equal to sum of these two squares, 400 square plus 430 square minus 2 times 400 times 430 times cos of angle 5 degrees square root. So let's find the magnitude first, right? So we have 400 square plus 430 square minus 2 times 400 times 430 times cos of 5 degrees. Right? So we get this as equal to some number and we'll do square root of this number. 47. So we get this as a magnitude of 47. So wind velocity is 47 kilometers per hour. Is that clear to you? So we got this as 47. Now the idea is to find the angle also, right? Without that, it is incomplete. Vectors means you need to find the angle. So it's a good idea to find this angle. Let's say this angle theta we'll find. We'll use sine law now. So sine theta over 430 is 430 is equal to 47, which is angle 5 degrees, sine of 5 degrees over 47. Is it clear to you, right? So from here we get sine theta equals to 430 over 47 times sine of 5 degrees, right? Let's figure this out. So we have 430 divided by 47 times sine of 5 degrees, right? Which is 0.79738. So let me write 4. So theta is sine inverse of all this, 0.7974, right? So which is shift sine inverse of our answer, which is 52.88. So this angle is 52.88 degrees, correct? So when you are describing the angle, how are you going to describe this angle? So there are a couple of ways in which you could do it, right? So this is the angle. You can say it is the same as this angle, correct? These two angles are equal. So you can say that the wind velocity has a magnitude of 47 kilometers per hour and direction is So from north, it is you can say 52.9 degrees west. Is that clear, right? So from north, it is 52.9 degrees west. So that is how we are going to answer this particular question. I hope that makes sense, right? Now let's take the next question, which is question number 13, and the last will be question number 14. Okay. A 25 Newton force is applied at the end of a wrench that is 40 centimeter in length. The force is applied at an angle of 30 degrees to the wrench, right? So calculate the magnitude of the torque about the point of rotation. Well, so torque is equals to cross product of these two, right? So we have magnitude of 25 newtons times magnitude of 40. Now, Newton meters, right? So this is given in centimeters. So therefore, we should write this as 0.4 Newton meters, right? Times sine of the angle, which is 30 degrees. Correct? So that is going to be our solution. Perfect. So let's just figure this out. So we have 25 times 0.4 times sine of 30 degrees. So sine of 30 degrees purposely we have taken, since it is just 5, basically it is easy calculation. So that is Newton meters. Is that clear to you? So that much of torque is being applied to the wrench. Question 14. Explain without calculating the cross product y j cross k equals to I. Now this is a very important communication question. Let's try to understand how to explain it. So let's get back to our R3. So when I say j cross k, it really means what? Yeah, these are unit vectors, right? So j is this, right? This is j, right? And k is this vector. So when we say j cross k, so j cross k, these are area. So the magnitude of j cross a basically is the area, right? Now both are 1 unit and 1 unit. So the area of 1 unit square. Is that clear to you? So we kind of make a square here. So that is what is j cross k, right? Now how about the direction? So direction is given by right hand rule. Correct? So when I say j cross k, right, so we are talking about y and z axis, that is x. So if I do like this, from j I'm going to k, right? So when I'm going like this, the thumb is pointing in this direction, right? So it is going outwards. So a unit going towards x-axis, right? So direction is same as, so it is going in the direction of unit vector I. Now since the magnitude is also 1, so we say j cross k is I. Does it make sense to you? So it is 1 unit in the direction of x-axis, and therefore this is I. Does make sense to you? Unit vector I. So that is how you could explain it. So I hope with this you understood how to solve a test paper of Unit 2, where we involved some basics about dot and cross product. We had few limited applications. You can actually watch my videos on application of vectors separately, where we have extensively worked on force, displacement, torque, and such applications. Feel free to write a comment, share your views, and if you like and subscribe to my videos, that'd be great. Thanks for watching and all the best.